All right, so welcome. We are going to be getting into chapter 10. So I did notice a few things on chapter 10. This book has actually taken chapter 10.5 and put it kind of mixed in with chapter 10.1. So I think they still had an old thing on the syllabus that I copied into, of which time, and it used to be 5 sections. There's only 4 sections, so we're going to kind of split it up a little bit differently. This week, you're going to get chapter 10.1 and 10.2, and then hopefully sometime at the end of the week, I'll get you 10.3. A couple of these are really long PowerPoints, and so I'm going to go through them kind of quick. The fact that they're being um, the fact that we're doing these and we're videotaping the PowerPoint, you can stop, read it if you really need to, um, and just kind of go through the things we're going through. So let me go ahead and get sharing on what we're going to be dealing with here. All right, so we are talking about chapter 10, which is data. And so some of the stuff you're going to find, especially on homework, so you're just maybe reading a lot of things, reading graphs. We're going to talk about collecting data, a little bit on the variability of data, not a whole lot. Difference between survey and sample populations, misuses of statistics, which used to be in the 10.5 section. That's kind of where this gone. So also some inferences and stuff like that. So we're going to kind of go through this. So it says introduction and variability. So much of the study of statistics deals with variability of data, or the amount of pieces of the data in the data set differ. Okay, so we're talking about different ideas with this. It's important to understand different types of variability when designing experiments and examining. And that's the big thing about in your classes. We're going to be talking about how you want your kids, if they are doing something that has data and statistics in it, very, very, very basic statistic stuff. Okay, on is it going to be viable? Okay, so suppose you ask 20 students to measure the length of a board. In a perfect world, all the measurements would be the same. However, simple human fallibility will produce different results. Okay, and what that just means is, every board might be supposed to be 6 foot long, but some are going to be just under 6 feet, maybe just a little bit above 6 feet. Okay, and so that's measurement. You not always get exactly the same. Okay, you might have some experimental variability. Okay, it says experimental variability is frequently studied to see how different treatments cause different results. So, when you're doing experiments, you may get a different result than you think you're going to get, or that you got the last 5 times. And that's why they do them many times, just to make sure it's solid. Okay. And then sampling variability, if we choose, for example, a set of college students to see how they react to a question. Okay. You ask them a bunch of people the same question, you're going to get a bunch of different answers. Okay, so some ways might elicit a reaction that could be judged as representative of the entire population, and others might not. Okay, take it right now. Go onto a campus, ask somebody a politics question. You're going to get people that are solid, of what they're somebody talking about that might represent the whole campus, and then somebody who's going to be like an outlier. Okay, so you have to take that into understanding what some of your information is going to be. All right, samples. A random sample, okay, is one that such each member of the population has the same chance of being selected. Okay, so you got a room full of people, you're drawing names, that's a random sample. Okay, simplified sample is the sample such that any subset of the population has the same chance of being the sample as any other subset of any same size. So just even a smaller sample, you can take a small sample out of another sample, basically. People sometimes deliberately use statistics to mislead others. This can be seen in advertising. So, Think about if they would have made this slide this year. Okay. So you want to see misuse statistics? Go watch every uh, national newscast you can. You will see statistics. It don't matter what side. This is not politics. You just go look at both. I've watched all of them, and I see just misuses of statistics. Why? You know, because it helps it once they're trying to lean a certain way. So more often, how the misuse of statistics is the result of misinterpreting the data and statistics mean. Okay, now that statement right there, I mean, some of that is because you're just not reading your data right because of the variabilities. So suppose 1 million people nationwide were sent on a survey and only 50 responded. This would mean that there is only a 0.5% response, which would certainly cause a mistrust in the ad. Okay, 1 million people, you only talk to 50, you're really not taking much of a sample space. That's an abuse. Small sample space. Go into a senior citizen home and ask one person what they think about today's world. You're not going to get a very good idea of what their sample is. Of the 50 responding in this one, suppose 49 of the responses were affirmative for what you wanted, 98% claim. But is that true for the whole sample? No, because that 50 is only 0.5% of 1 million people. So really, I mean, that big of a sample or small of sample space in a big number just doesn't work. Suppose a survey read, Buff-Pen is the best pain reliever I've tried for headaches and arthritis, and there was no question about the kind and type of other pain relievers tried. Okay, well, you only try one thing, you're not going to get very good statistics. Again, abuse. Suppose all the people who received the survey were chosen from a town in which the major industry is this company. What your answer is going to be of who has the best pain reliever? Well, they all work there, or know somebody that works there, or it's a relative of somebody that works there. You're going to get a very biased answer. Okay, you want your questions to be unbiased. Suppose only 2 pain relievers were tested whose active ingredients are 100% aspirin. Okay, this company uses 100% aspirin and the placebo containing only powdered sugar. So if you're going to use a placebo in which you really should in your statistics, you need to have more than 1 pain reliever, probably. Okay, so consider the advertisement reporting that of the people responding to a recent survey, 98% said that Buff-Pen is the most effective pain reliever in headaches, arthritis. Is that, it could be true, but is it leading? Okay, of course it's leading. If you know all that information, that is a definite leading question. To certify that statistics are not being misused, the following information should be reported. The questions being asked are important, okay? They ought to be to the point and good for that survey. The number of people surveyed should be proportional to the bigger group. You're not going to be able to survey everybody, but you want to get a good size. The number of people who responded, okay? So you send out 50 surveys out of 100, that's half the people. That's not bad, but if only 2 people respond, it's not going to be a good survey. How the people who participated in the survey were chosen, okay? Well, if you wanted to ask a survey of who likes your grandma and you're only going to ask your family, everybody's going to like grandma, okay? Well, who doesn't like grandmas, right? The number and type of the pain relievers tested, okay? Maybe a good set of it and how they're tested. How the answers were interpreted is important, okay? If you only have one person interpreting it, it's gonna be biased. Without this information, many situations are possible, all of which could be misleading. Now, let's look at this one. It says, which of the following might provide a random sample of statistical study for cafeteria food choices in a school? Okay, and why? So there's a collection of students on a playground who do not eat lunch in the cafeteria. Okay, so you're going to study the cafeteria food, but you're only going to talk to people that don't eat in the cafeteria. That would be bias. Okay, shouldn't you? If you're going to ask about the food, they should have tasted the food, right? Talking to a collection of students at a single table in the cafeteria. Okay, well, they're friends, probably, if they're sitting together. One table, not a very big sample size. Okay, and they are probably very similar kind of people. Okay, it says as the people who are eating together at the table may have influenced each other's choices in the cafeteria. Let's talk about this next one. Every fourth student entering the cafeteria on a given day. Well, that's random. You're not picking a certain group of people. And a fourth of the, of the people, not too bad. It says, 25% is not a bad number. You would like to go higher if you can. But it is random, which is good. It says, however, this set of students could be influenced by absences due to field trips or other school activities. Activities biasing the sample. It's better. It's more unbiased than the other ones. Every fourth student entering the cafeteria on a random day. That's very random in two ways, so that's good. Okay. All right. So the following underlying issues in designing studies. Okay. It says the following framework for statistical problem solving was suggested for the classroom. Formulate a question, collect the data, analyze the data, and interpret the results. So those are your basic investigation, your labs that you do. You've got to formulate, okay, what are we trying to find? What's our question going to be? All right, go out and get some good data. Don't make sure it's unbiased data because we want unbiased data. Okay, then you can put your data together and let's look at the data. A couple people look at the data, keep it unbiased, and then let's get a final interpretation of the results. Are we right? Are we wrong? Is it going to lead us a certain way? Okay. Formulating questions for any given problem of data are needed to determine either an answer or an approach to an answer. It is important that the problem is clarified and the extent that meaningful data can be collected. If you don't have a good collection, it's a good questions, it's hard to get good data. Okay, just for example, if we want to collect data on an appearance of an average fifth grader, we must clarify what it means to consider the appearance of an average fifth grader. What are we talking about? Appearance? Clothes, hair, acne, all kinds of things, right? That's probably not the greatest question. It says evaluate the questions describing any bias or other expectation if they were asked in a given school classes. So we're talking about a first grade. Do you have a pet? Okay. Now, really, you could use it as statistics, but it's really not much of a statistical question is what they're labeling it, okay, as it is a deterministic, okay? Maybe be more specific. Do you have a dog as a pet or something like that? Okay, fourth grade. How many good pets does each student in the class have? Okay, what's the term good mean? Okay, that makes it bias. Do students have more pets per student as they progress from grade 1 to grade 7? Okay, now this is solid. You know what you're talking about. You're looking at the numbers of pets as they grow older. A much better question. Okay, so you want to be clear on our questions that we have. All right, so the next step is to develop a plan for collecting the data. Okay, so let's go get our data. How are we going to get data? Who are we going to ask? Where are we going to ask? All those things are important. Okay, asking questions about the weather on a rainy day might not be the best thing in the world. Okay, asking questions about taxes on April 15th might not be a good day to ask about taxes, right? And an immediate question is from whom and where the data have to be collected. Okay, we talked about that. The context is important. For an individual's health blood drawn, a technician inserts a needle in a vein and takes a sample. How is this collection? Okay, what are we collecting? Is it going to be a good randoms? Okay, well, you can't just pick what kind of blood you're going to get. Okay, you just put it in, and you're getting the blood. It's circulating throughout, so it's a very random sample. Even though if you take it in one arm or the other arm, it's still a random sample. Okay, so that data you're collecting is going to be very random, which is good. So in a U.S. Census, every individual is by law counted. Typically, interviewers collect data. They go around, discuss this as a collection of data. So we're talking about the actual person going out and collecting the data. Is that going to be a good, solid data of the census? Well, now we don't do that as much. It's more of mail-in, computerized, where it helps a little bit more. People don't like mailing things. So think about, is that going to be, is that a good collection of data? Okay. It says a census is designed to poll the entire population of the country. In this case, there is no randomness involved in this collection. Now, the randomness might come into play that if every interviewer out there is going to ask the exact same questions with no bias, that's fine. Okay, now you're getting a whole bunch of people. But, just asking people in Texas or whatever the case may be would not make it as random as it needs to be. All right, so then analyzing the data. In analyzing collected data, we must make our decision about how to display the data and whether to report numbers to summarize them. So you're getting numbers, you're getting data, depending on what it is. Not always numbers, okay? But you also have to show how it's going to look, analyze it, put it together, get good information, what works, what is the parts that we're getting, be willing to take the bad stuff with the good also, and analyzing the data, okay? It also says how to display the data. So when you are giving data, you want to have it sort of displayed to everybody. And we're going to talk about displaying data in the next unit. Often decisions about how to analyze data will be made with the data in hand. However, a good plan for collecting data should include some consideration of how you're going to display it anyway. All right, and then interpreting results. The results of data analysis must be interpreted. Some interpretations are clear-cut. Others must sometimes misuse data or just aren't as clear-cut, okay? So this is where we come into play now. You're going to, you watch these people talk about data all the time on TV, okay? How are they using it? They may think they're very clear-cut, but then somebody else reads that data and it's like, well, that doesn't seem clear. Okay, how is that actually proper? Okay, and that's where your data comes in important. Okay, we want to teach the kids to only stick with their data. Okay, interpreting data is reading it black and white. Okay, how did your data come about? Okay, how is this? Then, if you want to lead them into projecting that out, now we're talking about some of your ideas, okay? But you can't just, oh, well, this is 1 out of 20, so that must be true because I think it's true. And that's where it comes into play, okay? So it is very difficult. Now, my biggest things on this section is making sure you know what the difference between bias and unbiased questioning and data, and trying to make sure you're getting that clear cut. I may have some questions on that too. All right, so I hope this helps. Okay, let me stop sharing. And that's going to be 10.1. We'll get into 10.2 next. And that'll be this week, and then 10.3 and 10.4 mostly next week.